Hello, Miss Barron here. Today I'm going to be going over how to write formulas when you get a new compound or product. This usually will happen if you have a chemical reaction. You have the two reactants that will react, and then you get the products. Oftentimes the new products will be some type of a ionic compound. And I'm going to be going over how we figure out the correct formulas for those ionic compounds. So I have an example here. So let's say I had some type of reaction where I combined lithium and oxygen together, okay? So I did lithium plus oxygen, okay? And I would get lithium and oxygen combined together. So this is how I would figure out what that formula is. I call this the crisscross method. I do things this way just because it's a very quick and easy method to determine the correct formula for a new compound. So lithium on our periodic table, it would have a charge of +1. So if I go to the periodic table, lithium is right here, okay? This will be written on your copy of the periodic table, which is the charges, okay? So this will be always provided to you if necessary. So on our periodic table here, you find the elements, in this case lithium, and you look at what group it is in. It's in group 1. And group 1 as an ion would form a charge of +1. So lithium would be +1. And then chlorine, which is in group 17, it would have, oxygen. That's what we're looking at. Oxygen here, which is in group 16, as an ion would form a charge of -2. So that's where I'm getting those charges from. So since lithium is +1 and oxygen is -2, what I do is a crisscross method, okay? This is how I'll usually represent it or draw it during class. So you'll notice that the number for the charge, this is +1, becomes the subscript for the other element. So this 1 here, it's going to become the subscript now. So usually I'll do it like this for the oxygen. Now it's just the number, it's not the charge itself. Now in chemistry, we don't write the 1s, so that's why the 1 is not shown here, okay? Because we're not going to write it, because you already know there's 1 oxygen there. And then the 2 on the charge from the oxygen becomes the subscript for the lithium. So this 2 would go here. So that's why the formula is Li2O. And this makes sense because you've made a new compound. A compound is when you have 2 of the same element or 2 different elements bonded together. And that overall charge should be 0. So this makes sense because if lithium is +1 and oxygen is -2, you would need 2 lithiums to balance out with the charge of the -2 on the oxygen. So that's why the formula makes sense. Li2, 2 lithiums, and then 1 oxygen, so Li2O. So I'm going to do a couple more examples, and I will also include some polyatomic ions as well, because those are usually the most challenging. So let's say we're doing some really simple formulas here. Later in the semester, we'll be doing a little bit more complex of things, but we're going to start simple. So let's say I'm going to combine magnesium and chlorine. Okay, so this would create magnesium chloride. Now here's how I would figure out the correct formula. Now, one thing I will mention is the reason I'm writing it as Cl2 is there are elements that when they are by themselves, they are diatomic elements. So these are elements that like to bond together, and they're always written like this. And that includes, I remember Hunkelbrief, so hydrogen, oxygen, nitrogen, chlorine, iodine, and bromine. Okay, so all of these elements, hydrogen, oxygen, nitrogen, chlorine, iodine, bromine, when they are by themselves, they are written like this. Okay, just a side note there. All right, so what I'm focusing on is when I combine those two elements together, what is the new compound going to be? So I always just start by writing the two that go together. I am not going to be necessarily copying over this 2 over here, okay? Since you are forming a new compound, it's not going to always be the same. In this case, it will be, but that might not always be the case. So I just start by writing the two things that go together. Next, I'm going to figure out their charges. So if I look at my periodic table, magnesium is right here, so it would have a charge of +2. Chlorine is right here, and it would have a charge of -1. So I'm going to go ahead and write those charges on these guys. So this is +2, and this is -1. So again, I use the crisscross method. It's just very easy, quick way to figure out the correct formula of something. So this 2 will become the subscript for the chlorine, and this 1 will become the subscript for the magnesium, but we don't have to write the 1. So for my final answer, I would have, I'm going to erase this, I would have MgCl2. That would be my final answer. That would be my new compound that would have formed. Let's move that over a tad. Okay. All right, let's do an example with some polyatomic ions. Okay, so let's say I have calcium and we have NO3. NO3, that is nitrate. So if you see something like this, this is when you're going to have to look at the back of your periodic table. So here I have, this is what the back of the periodic table looks like. This is the polyatomic ion table. So I have listed here all of the polyatomic ions and their charges. So poly meaning many, so there's more than one element and it's an individual ion. So you want to treat these guys as if they were individual elements like these up here, okay? So the nitrate is right here, and that's NO3, and it has a charge of -1. So that's where I would find the charge of something like that. And then the calcium is up here, and that has a charge of +2. All right, so again, I'm just going to write that these two now are together. And now I'm going to put my charges in. So the calcium was +2, and the nitrate was -1. So now I'm going to do my crisscross. So this 2 will become the subscript here, and this 1 will become the subscript here, but we don't have to write it. Now, here's the thing with the polyatomic ions. Because you're treating this as an individual, you're going to have to put it in parentheses. So I'm actually going to write my final answer down here. So we know the calcium, this has a 1, but we don't have to write it. And we know the NO3 is going to have a 2. So what we do is we put that NO3 in parentheses because we're treating it as if it were an individual element, and I would put the 2 on the outside. This is saying that you have 2 NO3s. That 2 gets applied to everything in the parentheses, okay? So that would be my final answer. And I know that this is not balanced, so normally this would have a 2 here so that the overall chemical equation would be balanced. All right, so now I'm going to do a little bit more difficult. So let's say we're going to just have a double replacement reaction. So we're going to actually take that CaNO3 and we're going to react it with that MgCl2. okay? So, and we'll get to these types of reactions as well later on. This would be a double replacement reaction. So these compounds that we have, they're going to kind of switch partners with each other, so to speak. So this is a double replacement reaction. So what I do is I switch the first two elements with each other. Okay, so this is double replacement. So now the Mg instead is now going to be with the NO3, and the calcium is now going to be with the chlorine. Okay. Actually, I'm going to do a little bit different of an example here, just so that I do have, so you could see some differences. So instead, I'm actually going to do I'm going to use aluminum, and I'm going to use a hydroxide. Okay, we're going to do this instead. So that we're going to do a double replacement. So we're going to switch the first element in the compound with each other. So the calcium is now going to be with the OH, and the aluminum is now going to be with the NO3. So this is how I do a double replacement. So I switched likes with likes. So this guy switched with this guy. Okay, so now they're with the other one's element or polyatomic ion that they were originally with. So we're going to write what goes together, and then you're going to do the same thing with the crisscrosses. So calcium is +2, but now we're seeing another polyatomic ion, which is the OH. So something like that you would also find on the back of your periodic table. So OH is hydroxide, and that has a charge of -1. Okay, so same thing. When I go to do the crisscross for this 1 becomes a subscript for the calcium, but I don't have to write it. And this 2 becomes a subscript for the OH, but since the OH is a polyatomic ion, we're going to put it in parentheses, okay? So we have that compound, and now we have to do the other one, which is the aluminum and the nitrates. So we already know that this one was a charge of -1, but now we need the charge of aluminum. So that's on the front of our periodic table. So aluminum is right here, and it has a charge of +3. So this would be +3. So we would do the same thing. We would do our crisscross. So this 1 becomes the subscript for the aluminum, but we don't have to write it. And this 3 becomes the subscript for the NO3. But since the NO3 is a polyatomic ion, we're going to have to put it in parentheses. So I wanted to do this because I want to point out, notice that it's NO3 2 on this side, but it's NO3 3 on this side. And that is okay, all right? Because the relationship between the calcium and the nitrate here is different from this new compound that we made, and the relationship between the aluminum and nitrate is different here, okay? So whenever you're doing a double replacement reaction like this, you just want to write what elements go together, find their charges, and then do the crisscross. I will go over balancing the overall chemical equation in a different video. And then here are some, and then I will write in some examples for you to do as practice.